Greetings, everyone. I'm Patrick Veazey with NC State University. Today, we're going to be continuing our multi-part series on substrate pH with e-GRO. And today, we're going to be focusing in on alkalinity and taking a little bit of a deeper dive in terms of alkalinity and water quality. Now, the first step in looking at alkalinity and water quality and providing recommendations is knowing your water quality and testing annually. Now, your water will vary even in the most purest sense year to year and season to season. We see the most variability in surface water, followed by well and city, with being the least amount of variability. But also, that season to season variation and well to well variation can occur, especially with wells. If you have multiple wells on site and there are different depths, we've seen variation there, as well as in the summer months when that aquifer starts to drain down a little bit, or that surface pond starts to drain down, we see that variation starting to occur. And then knowing your alkalinity as well as knowing your pH. Your alkalinity will impact your substrate pH more than the pH of your water. And this is because alkalinity is essentially flowable lime that you're pouring into the pot. And how do we account for that in making changes into our growing practices in order to promote target pH? So looking at your water testing results, they can be reported in a variety of ways. They can be reported in calcium carbonate equivalents or milliequivalents or bicarbonates. So if we convert all of that into milliequivalents, and we can look at that all in the same field, but understanding what your lab's going to report it back to you in terms of looking at different recommendations in order to correct that. It can kind of be broken down into low, marginal, and high. When we have low buffering capacity, substrate pH may drop over time, and using a more basic fertilizer that's higher in nitrates can be used to help amend that. You have marginal, where acid injection may help, and a neutral or acidic fertilizer to maintain a substrate pH can be used. When we get high alkalinity, greater than 4 milliequivalents, acid injection is going to be required in order to drive that pH into the target range. So looking at target alkalinity ranges, there's not one size essentially fits all. For container size, it varies greatly. So looking at a very small container in a small root zone, we're going to be looking at a lower maximum alkalinity of about 1 milliequivalent. And then in 4 to 6 inch pots, being the greater, we can have about 2 milliequivalents maximum. So kind of understanding what are you growing and kind of what target alkalinity you want to be shooting for is also very important. So low alkalinity water, this is the problem here in the Southeast where we're not over limestone, and we have very limited buffering capacity in our water. If we have slight changes based upon our inputs, such as an acidic fertilizer, we can have low pH problems occurring due to that limited buffering capacity. And if you're in low alkalinity water, you really need to monitor that fertilizer type and its rate that you're putting in to prevent that pH drift over time. And then routine monitoring pH and EC in order to prevent that drift from getting too far outside of the ranges because you have that limited buffering. Now, in high alkalinity water, you essentially have a lot of dissolved limestone within the water. And this measures the water's capacity to neutralize the acid. It's generally mainly bicarbonate and also carbonate as well. We're more likely to encounter high pH problems compared to low. So looking for that intraveinal necrosis of the upper foliage associated with iron deficiency. Now, options for high alkalinity corrections. You can blend water, whether that's 50% well and 50% surface or 50% reverse osmosis as well. Acidic fertilizers. Now, an acidic fertilizer is generally going to be higher in ammoniacal nitrogen, and you can find the potential acidity or potential basicity on the guaranteed analysis of most of your commercial blends. So shown here, we have the potential acidity of 555 calcium carbonate per ton. Or in cases of higher alkalinity, you can utilize acid injection of either sulfuric, nitric, or phosphoric acid. And knowing your acid percentages when determining your injection rate is critical. And if you're going to be swapping between acids based upon making these different corrections, make sure that you know that acid percentage. And then going back to that point of substrate pH is greater impacted by alkalinity than your water pH. Shown here is grower A with a higher pH of 9.3, but a lower alkalinity of 1.4 milliequivalents, compared to grower B has a lower pH of 8.3 in their water, but a very high alkalinity of 6.2. If we want both growers to achieve a target pH of 5.8, we can see that grower A with a much lower alkalinity is going to require much less acid compared to grower B that's going to require almost 4 times because of that higher alkalinity in their water supply. It's kind of in summary and moving into the next part. Know and monitor your water quality. See the changes over time, test early and test often in order to see changes in your growing practices throughout the year. Select a fertilizer type to complement your water quality. If you're in low buffering capacity areas and low alkalinity, you have no buffering capacity, so you're going to need to use something that's not nearly as acidic to prevent that change in pH over time. Compared to a high alkalinity area, using a more acidic fertilizer to remove some of the alkalinity in your water is important. And then high alkalinity, corrective measures are required if you exceed 1 for very small plugs and 2 for larger containers. So understanding container size and your water quality is also very important. With that, I'd like to thank everyone, and we'll be going into more in-depth in fertilizer type and rate in the next video. Thank you.